Hi, so this session is on simplifying surds. So now that we know what surds are, for example, if I have the square root of 8, I know this is a surd because it's irrational, its decimal never ends, and it has no pattern. Now, I can leave the square root of 8 the way it is, but I can also simplify it. Okay, so, and simplifying means to make it, I guess, more simple. Now, to simplify surds, you have to remember the perfect squares. Now, if you haven't got this written down already, write down at least the first 20 perfect squares because you'll need to know what these numbers are in order to simplify surds. So, for example, 1 times 1 is 1. We don't really use this one, but if we keep going, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. So 25, and keep going because you need to use these perfect squares. These numbers here are very important. And if you don't know some of these, then you can't simplify surds. Now, with the square root of 8, I'm going to rewrite 8 in factor form. But I have to make sure one of the factors is a perfect square. Otherwise, it won't work. So can you think of factors? So something times something to give us 8, where one of those factors is a perfect square. I'll put a little, so perfect square. Now I know that 4 times 2 is 8. Well, first let's write down some of the factors of 8. Well, we know 1 times 8 is 8, and we've got 4 times 2 is 8, or 2 times 4. Anything else you can think of? So I think we'll stop there. Now we can't use 1 times 8 because that won't change anything. Yes, 1 is a perfect square, but you can't actually use it, or it'll stay the same. So I'll cross that one off. So I'll use 4 times 2, and I can see 4 is a perfect square. So now I'm going to keep the square root symbol that hasn't gone away. I'm making it longer because I'm going to write 8 as 4 times 2. I'll put an equal sign. That's my next step. So it's still 8. Now, the next thing I'm going to do, this is like a law or something you can do with surds, and that is I'm going to separate the 4 and the 2. They are still both under the square root, but I've just separated them. Okay, and we can do that. So these three things, the square root of 8, then this one and that one, they are all the same thing. If you put this into your calculator, if you put all three into your calculator, you'll get the same decimal. Okay, so this next step, I've just separated them. And you can see why I've done that. Have a look at this. The square root of 4, what's the square root of 4? The square root of 4 is 2. The radical sign, the square root, is gone. But I've got times the square root of 2. And we're pretty much done. We have simplified this surd. The other thing that we can do is just like with algebra, if I have 2x, or if I have 2 times x, we know it's the same thing, but we write our answer as 2x. So imagine the square root of 2, this surd here is x. Because there's a times here, that can become invisible. So our final answer should look like 2 square root of 2. And that's it. Now, if you put this into your calculator, see if you get the same decimal as the square root of 8. So 2 times the square root of 2, does it give you the same decimal as the square root of 8? Well, it should, and it does. And that's how we simplify surds. So remember, when doing this, you have to make sure one of these factors is a perfect square, because when you separate them, in this case, the square root of 4 gave us 2. If it wasn't a perfect square, we couldn't do that, and we would just be stuck with what we had at the beginning. Let's try another example. So I have some of my perfect squares just here, just to help me to remember what they are, and I'm looking for these factors. So if I have the square root of 12 as my next example, so example 2. Now the number 12 I know has quite a few factors to give me 12. So for example, I've got 2 times 6, I've got 4 times 3, 12 times 1, and so on. So there are quite a few factor pairs that I can use. Which one should I use if I want to simplify a surd? I pick one that has a perfect square. And you can see that out of these numbers, the only one with a perfect square is this one here. And yes, 1 is a perfect square, but we can't change it. So we won't use that one. 2 times 6, 2 is not a perfect square. And is 6 here at all? No, we can't see 6, so we can't use that one either. So we'll use 4 times 3. So now our next step is to write 12 as 4 times 3, still under the square root. And now let's separate them. So 4 times 3. And I like to put my perfect square first, so it's on this end here. And then the square root of 4, that's easy, that's 2 times the square root of 3, and we're done. But just like in algebra, the multiplication symbol becomes invisible, and we have simplified our surd. That's it. Now try the square root of 30. Now, if you started writing down some factors of 30, you might have 6 times 5, 15 times 2, 30 times 1, but we know we can't use that one because it won't do anything. Now, can you think of any more factors that will give us 30? Now, if I use these numbers here, these factors here, are any of these numbers 6, 5, 15, and 2 perfect squares? No, they're not. So it's actually impossible to simplify the square root of 30. This is just going to give us the square root of 30. We can't actually simplify it, and that's because none of these numbers, its factors, are perfect squares. So we can't really do anything. Because if I tried using this one here, for example, if I have the square root, instead of 30, if I have 15 times 2, and then I separate it, so square root of 15 times square root of 2, what can I do with this now? The square root of 15, is it a whole number? No, it's irrational, it's a surd. And the square root of 2 is also irrational, so we can't actually simplify these. Now, here we have the square root of 24. Now, I forgot to mention that when doing this, sometimes a number may have factors, more than one factor that's a perfect square. Always go for the largest factor that's a perfect square, so it's less working out. So what's the largest factor of 24 that's a perfect square? Well, I think for 24, once again, our perfect square, the largest perfect square will be 4 times 6. That gives us 24. So I'll write it as this, 4 times 6, and then separate it. So 4 times square root of 4 times the square root of 6. Perfect, this is a perfect square. Square root of 4 is 2 times square root of 6. And just do a check. Can 6 be broken down further? Can it be simplified? No, because 2 times 3 is 6, and 2 and 3, they're not perfect squares, so we can't do anything else. Now, for our last example, I'll give you a hint. Before you do it, make sure that the perfect square that you use is the largest perfect square. If you don't, that's fine, but you may have to keep working it out. And I'm going to show you how to do this both ways to show you what I mean. But please have a go first. Now, the first way I'm going to do this, so I'm going to show you 2 ways. This is the first way. The factors that come to my mind straight away, because I know my timetables, is, well, I know that 4 times 8 gives me 32. And 4 is a perfect square, so I can actually use this, and I will. So that's my first step, to write 32 as 4 times 8, because 4 is a perfect square. Separate it. And then the square root of 4 is, that's pretty easy, 2 times the square root of 8, which is just the square root of 8. Now we have simplified it, but what do you notice? The number 8, can it be simplified further? Yes, it can, because I know that 4 times 2 is 8, and 8 is also a perfect square. Oh, sorry, 4 is also a perfect square. So this part may trick you, but you understand it better as we continue with this chapter. Now, once again, there was a times over there, so I'm going to write 2 times. Now, I'm going to leave this 2 times for now, and I'm going to focus on the square root of 8. So the square root of 8, the number 8, can be written as 4 times 2, okay? Don't let this number here, 2 times this bit, confuse you. Pretend the 2's not there for now, but I'll keep writing it so I don't forget to put it there. Now, once again, separate these two. So square root of 4 times the square root of 2. And now, finally, the square root of 4, this just gives me 2. So I'm left with, ready? That 2 was already there from before. 2 times the square root of 4 is 2. And then times the square root of 2. And now, if you have a look here, see how we have 2 times 2? 2 times 2 is 4. They're both whole numbers, so we can actually do this. So I'll finish it up here. So we end up with 4 times the square root of 2. So finally, we end up with 4 square root of 2. So you can see how this way here looks, it took up more space, more working out, and it probably confused you a little bit. And that's because we didn't pick the factor of 32 that was the highest perfect square. Because, in fact, the highest perfect square of 32 as a factor is 16. And 16 times 2 gives us 32. So we should have used this factor here, these factors here, because 16 is a perfect square. Because 4 times 4 is 16. So if I had have used this straight away, you ready? I would have avoided all this working out, because I would have simply had done this. Well, I know that 32 can be written as 16 times 2. I separate them. Square root of 16 times the square root of 2. Square root of 16 is just simply 4 times the square root of 2. And we're left with 4 square root of 2. Can you see how we got the same answer as the first attempt? They're both simplified to the same thing. It's just that this one involved more working out, and both ways are right. But just remember that if you simplify something, always do a check. Can the number under the square root, in this case the 8, could it be simplified further? Yes, it could. This 2 here, can that be simplified further? No, it can't. We just stop there. So what I want you to do is to have a go at simplifying the following surds, if possible. And I'll put the answers up for you, but you still have to show all the working out. So most of the answers are there for you to check your working out, but please make sure you have a go. Thank you.